Hello, my name is Zachary Howell, and I am the team lead for this year's Colorado School of Mines Shell Eco Marathon Senior Design Team. I will be presenting a brief elevator pitch on behalf of the rest of my team, which includes the chassis sub-team lead, Shelby Ryan, the drivetrain lead, Alejandro Martinez, and the electrical lead, Cameron Kramer. Every year, teams from top academic institutions around the world compete in Shell Eco Marathon. This event, which started in 1939, is a competition in which thousands of high school and university students challenge each other to build the most efficient automobile. This year, the Mines Shell Eco Marathon team was presented with a novel challenge. The Eco Marathon was canceled due to COVID-19. A lesser team may have seen this as a chance to coast for the remainder of senior design. This year's team, however, saw this as a unique opportunity to design for the success of future Mines teams. Rather than build an entire vehicle from the ground up, the team set out to develop a robust, modular electric propulsion system. Future teams will be able to easily incorporate this system into their vehicle so they may focus on other core vehicle designs. The chassis sub-team was tasked with designing a frame on which the rest of the propulsion system can be mounted. The design chosen by the sub-team was a lightweight aluminum structure comprised of an iso-grid patterned backplate and a thin-walled tubing array. The backplate contains evenly spaced threaded mounting holes for modular component installation. This design is chosen because it minimizes weight, therefore increasing efficiency, while still staying above an appropriate factor of safety when subjected to nominal loading conditions. The drivetrain sub-team was tasked with designing a system that efficiently transmits power from the motor to the rear wheel, therefore propelling the vehicle forward. The design chosen by the sub-team is a single-speed drivetrain with an adjustable gear ratio. The key component of this system, which could not be bought off the shelf, is the drive sprocket coupling. This design was chosen because it maximizes the amount of power transmitted from the motor to the tire while maintaining an adequate factor of safety at high stress locations. Additionally, it allows for future teams to adjust chainring sizes to better match their vehicle configuration. The electrical sub-team was tasked with designing a system that can efficiently manage and direct power. This design, chosen by the electrical sub-team, is that of a single board distributed system. This system is comprised of a power, motor, and main battery controller boards, and is connected to the battery and the motor through use of wiring harness. This system was chosen because it balances efficiency, expandability, adjustability, and modularity. Additionally, the use of individual boards ensures that any fault in the system is localized, therefore allowing for quick troubleshooting of issues. At this time, nearly all of the designs produced throughout the course of the project have been fully physically realized. However, there are still a few remaining action items that separate the current physical product from the final design. These include the production of the main board for the electric subsystem, the full installation of the derailleur component for the drivetrain subsystem, and sustained load testing of the propulsion chassis for the chassis subsystem. The next steps for the current team are largely focused on passed-down documentation. This documentation will not only give instructions on how best to complete the action items discussed before, but will also enable future teams to seamlessly integrate the propulsion system into their vehicle design. And with that, I'd like to conclude this elevator pitch. If you do have any questions and you happen to be watching this at the time of the design showcase, please feel free to stop by in our Zoom chat and we would be happy to answer them. Thank you very much for your time and have a great day.